So far we've talked about strong acids, strong bases, weak bases, and how they affect the pH. What we're going to talk about now is something called a buffer. And in this video we're going to talk about what a buffer is and then how you can identify a buffer. Let's start with defining a buffer. A buffer solution is a solution that resists changes to the pH when hydrogen ion or hydroxide ion is added to the solution. We know that normally if we add hydrogen ion, the pH will drop rapidly. If we add hydroxide ion, the pH will rise rapidly. But when we have a buffer, we can add that acid or base and the pH will stay essentially the same. Notice that it doesn't say it's going to be pH 7, which is neutral, but it will be at the same pH as it originally was. Buffers are important in lots of ways. One of the most important buffers we see is the bicarbonate buffer, which is found in our blood and keeps the pH the same within our blood. That means that I can drink a glass of lemonade and not have my pH plummet, or I can have a cup of coffee and not have my pH rise up. So how does the buffer work? Well, what a buffer does is it reacts with any added acid to make it neutral. And it reacts with any added base to make it neutral. So whenever I add the acid or the base, they go through a reaction so that they are no longer acidic or basic in this buffer solution. In order to behave as a buffer then, we need to have something that neutralizes both acids and bases. And so a buffer solution must contain two components. It must have at least one component that can react with added hydrogen ion, and it makes a weak acid or water. And it must have another component that can react with hydroxide ion, which produces a weak base or water. In either case, what we're producing is something that is more neutral than the original substance. So we already know that in neutralization reactions, when acids and bases react, they produce water. So that means if I have acid, if I add base to it, I'll get water. So I know one of the two components could be something like that. Or if I have base and I add acid to it, of course I'll get water. But what will be something that would produce a weak acid or a weak base? Well, to produce a weak acid, we'll need to start with a salt that originally had one of the ions that made the weak acid. And to produce a weak base, we would need to start with a salt that had the ion that creates a weak base. So when we look at a buffer system, there are two usual types. The first type is something that is made of a weak acid and its salt. And what we mean by its salt is it is a salt that contains the anion of that same weak acid. Or we could have a second type, which is one that has a weak base and its salt. And again, that's a salt that contains the cation of the weak base. There are other common buffer systems, but in this class we're going to focus on only the ones that are weak acid and its salt or a weak base and its salt. The other ones are a little more challenging, so we're going to skip over those for now. So let's focus on the first buffer type, which is the weak acid and its salt. For this, we need to first identify some weak acids. So let's list a few here. We have HF, HC2H3O2, HNO2, and of course there's lots of other ones. But we're going to focus on these three for now. So now what is its salt? So let's start with HF. So HF is a weak acid and its salt is any salt that contains an anion of that weak acid. So the anion is the negative charge. That's the part that makes it weak when we talk about a weak acid. So we know the H says, hey, that's an acid. How do we know if it's strong or weak? We have to look at the second part, the anion. So in this case, the F minus is the part that makes it weak, and that must be present in the salt to make sure that this is a buffer. And how do we know there's something as a salt? It has to start with a metal or ammonium as the cation, and then there'll be some sort of anion. And in this case, we want to have exactly the same anion as we had in the weak acid. So a few different salts that would go with its salt for hydrogen fluoride would be something like sodium fluoride, calcium fluoride, aluminum fluoride, potassium fluoride. Any of those would be salts that came from hydrogen fluoride. How about for hydrogen acetate? Here again we see the hydrogen tells us it's an acid. The second part tells us it's a weak acid. That second part, the anion, is the part that has to match in our salt. So we might have sodium acetate, we might have lithium acetate, we could have magnesium acetate, we could have aluminum acetate. As long as it ends with acetate and there's hydrogen acetate present, then we know that we could have a buffer. And of course, for hydrogen nitrite, which is a weak acid, we will see that we can have something like sodium nitrite, cesium nitrite, iron 2 nitrite, gold 3 nitrite. Notice that they all have a metal and then they have the nitrite present. So those are all salts that could be its salt, making the mixture a buffer. So again, it must have both the weak acid and its salt to be the buffer. And how about the buffers that have to have a weak base and its salt? So far in this class, we only know of one compound that is a weak base. So of course we'll use that for example. That compound is NH4OH, ammonium hydroxide. This is often also known as ammonia, but as long as it's in water, it is actually having ammonium hydroxide present. And that is our weak base. So we identify it as a base because it has the hydroxide, and we identify it as the weak base because it has the ammonium ion. That ammonium ion must be the part that matches because it's the part that makes it into a weak base and not a strong base. So we're going to find a salt that contains the cation of the weak base, and that is your ammonium ion. So let's look at some examples. We could have ammonium chloride. We could have ammonium fluoride. We could have ammonium sulfide. All of those would make good buffers with ammonium hydroxide. And that is because there's both the weak base and its salt present. Now let's look at a variety of mixtures, solutions, to see if they are buffers. I'll do the first one with you, and then I'm going to have you try the rest of them. So the first step is to identify whether you have a weak acid or a weak base present. In this case, we have HF, which is a weak acid. Again, it starts with H, so we know it's an acid. The F tells us that it's a weak acid. And then the second part is to identify if we have its salt. In that case, we need to make sure that the part is not an acid or a base, is the part that matches. So here we have an F for HF, we have an F for NaF. It starts with Na, so that tells us that it is a salt, and then it ends with the F. So yes, we do have a buffer. And now it's your turn to try to identify which of the following mixtures are buffers. Pause the video while you go through this, and when you come back, I'll show you the answers. Okay, so let's start with HBr and NABr. So the first question, do we have a weak acid or weak base present? I see HBr, which is an acid, but this one is a strong acid, so we do not have the weak acid or weak base present, so immediately we know that this is not a buffer. Now let's look at HC2H3O2 and LiC2H3O2. So that's hydrogen acetate and lithium acetate. We see that we do have a weak acid, that's the HC2H3O2, and then we look to see if that other part matches, and it does. We're going to ignore the lithium, we're going to look at just the C2H3O2. It does match, so that is its salt. That one is a buffer. How about the next one? We have hydrogen oxalate and aluminum oxalate. And so we see that we have has H2. Is that still a weak acid? Yes, it is. The number with the 2 doesn't make any difference at all. It starts with an H. We know it's an acid. It's not one of the 6 strong, so this is a weak acid. And then it's going to go with the aluminum, which is a metal, so we know that that is its salt, and so we do have a buffer. How about H2SO3 and CS2SO4? So here we're going to start with finding the weak acid or weak base. It looks like we do have a weak acid. Now remember, H2SO4 is a strong acid, but H2SO3 is a weak acid. So we do have our weak acid, and then we're going to look to see if we have its salt. So here we have the SO3. On this side we have SO4. Those two do not match. This is not a buffer. And our next one, HF and CaF2. So hydrogen fluoride and calcium fluoride. We start with HF, which we know is a weak acid. Again, it starts with H, so it's an acid. The fluoride tells us that this is a weak acid. And then we look to see if the other part matches. Here we have an F, and over here we have an F2. Is that a match? Yes, it actually is. Some people think F2 means the molecule, but remember, this is with calcium. The 2 is there because the calcium has a +2 charge, and the fluoride only has a -1 charge. So yes, this is a buffer. Let's try NaNO2 and LiNO2. The first step, do we have a weak acid or weak base present? Well, we have the NaNO2, not an acid or a base, and we have LiNO2, which is not an acid or a base. So it don't matter if it's weak or not because there is no acid or base present. That immediately tells us this is not a buffer. How about the next one? Na2S and H2S. So we start by looking for our weak acid, and it's not listed first, but is it in the container? Absolutely. Remember, these are mixtures, and I've been listing them first, but there's no reason that the acid has to be listed first. So in this case, we have H2S, which is a weak acid. Remember, it's not one of our strong acids, so it must be weak. And then we need to see if it matches. So what is that? It's salt. We see that the anion is sulfide ion. Over here, the anion is sulfide. So yes, it does match. That would be a buffer. And our next one, NH4OH and NH4Br. NH4OH is our weak base. Remember, you do need to recall that there is only one weak base so far in this class. We may see some later, but you won't need to memorize them. But this is a weak base, and so we need to check if it's matched. So we're going to check the part that is not the base, and that's the NH4+. In this case, we have an NH4 on the other side, and so this is a salt. It's salt, and it makes this a buffer. And our last one, we have HF and CF4. So we start with HF, which is our weak acid, and then we look at CF4 and we say, is that it's salt? Well, it does have fluoride, but notice that this is not a salt. This is a covalent compound because it starts with carbon, which is a nonmetal. So this does not have the salt. This is not a buffer. In the next video, we're going to talk about the reactions that occur and why we need to have that weak acid or weak base and its salt in order to be a buffer.